This is the video for Wednesday and Thursday this week. For anyone that missed it or wants to rewatch it, um, I'll be asking questions, but you can always pause the video when I ask you to pause it, and then you can do some of the work, and then we'll answer it questions after. So, though my brain's not working very good, I'm making silly mistakes today. We'll try to keep going. So, find the x-intercepts of this quadratic function. So, how do you find the x-intercepts? We'll take a moment and find it. Pause me if you don't want to see it. I'm just going to get going. We know that x-intercepts are when f of x or y equals 0, so I'll set it equal to 0. And then we try to factor. How many terms? 2. GCF other than 1? No. Look at what's left, see if it can be factored more. Is it 4 terms? Is it 3 terms? Or is it a difference of squares? And I gave you a little hint up here. It's difference of squares. So we know it's a difference of squares because x squared's a perfect square and 25 is a perfect square, and we have subtraction. So what times what is x squared? Well, x times x. What same number times itself equals 25? 5 and 5. And with difference of squares, we get 1 minus and 1 plus sign. Great. Now, we just need to know what makes each parenthesis 0. And it looks like, for this one, it's 5. So there's one x-intercept. And for this one, negative 5. Negative 5 will make that 0, and 0 times anything is 0. Cool. So there are x-intercepts for this quadratic function. Any questions? Just kidding. Okay, so I did talk about that today we're going to be talking about solving quadratic equations, but we needed a new method. So this is method 2. I call it the no b term. You'll see what I mean. We might call it another thing later, but for now, this one, method 2 works if there's no b term. Okay? So take a moment, add these to your notes, or pause me. And then what I want you to think about is what values of x makes the equations true below. So take a moment, think about A, and then find me something for B. What can I put in for x that makes it true? Great, pause me if you don't want to see it. I'm going to keep going. Okay. We need to know 3 times what equals 12, and without doing really any work, we can find that x equals 4. 3 times 4 is 12. If we wanted to do it algebraically, we might divide both sides by 3. And you get x equals 4. So either way, we get x equals 4. Now, for this one, what squared equals 25? Can anyone think of it? Like, what would it be? What squared equals 25? Most people say 5. Yeah, right? 5 squared is 25. Is there anything else besides 5 that would also make this true? And someone would say, oh yeah, negative 5 also works. And I'd be like, yes, why does negative 5 work? Well, negative 5 times negative 5 is 25, right? Because a negative times a negative is a positive. So this equation has 2 values that make it true, either 5 or negative 5. Sound good? Okay. So you could do both of these in your head, but notice how I also showed that you can do something to both sides here. But we didn't do it here, right? Well, there's actually an algebraic way to solve that equation by undoing the second power symbol. Okay? So what would be a way to get the answer 5, what we could do to x squared equals 25. So what could we get x by itself? And we've kind of left it kind of unknowing at this point, right? But is there a math operation that you think might undo squaring something? And there is actually. So if I want to undo something squared, I can do, what would turn a 25 into a 5, right? So we're actually going to take the square root of both sides. A square root cancels out a square right here. So the square root of x squared, well, these two cancel out. And then we're left with x equals the square root of 25, which is 5. Sweet. So that's our new thing. We can take the square root of both sides, and we find our answer. Oh, wait, though. This has, we found that it works 5 or negative 5. When we take the square root, we only said 5, but there's two answers, right? 5 and negative 5 both will work here. If I take the square root and I only, but it's positive and negative 5. So here's the new thing. And this is why we haven't showed you up until this point, maybe in 8th grade. Teachers might have taught you earlier, maybe say, just on, if you had extra time. But when you take the square root of both sides, you get two answers. A positive and a negative. So we actually don't have, the answer is 5, but we notice that it's positive and negative 5. So this is like a new symbol as well. If you want to say both positive and negative 5, you can use plus minus. Okay. So I would encourage you also, when you take the square root of a number, when we're doing that now, we're going to put a plus and minus right in the front there. Positive or negative, square root of 25. You've seen square roots before when you were finding the length of the hypotenuse in a triangle. But when you have length, you only want the positive version. But because we're not finding side length, we can have positive or negative answers. Okay, so here's our example. We're going to look at this, and we're not going to set it equal to 0, because if you did, you would notice that there's no b term if you set it equal to 0. You'd only have an ax squared and a c term. So if you don't have a b term, you can do this. So we have something, 16 times x squared equals 36. We're going to solve this for x. Okay. Now, just like if this said plain old x, we're going to undo stuff to get this by itself. So we have 16 times x squared. I'm going to divide both sides first by 16. Then we get 16 divided by 16 is x squared. And we'll leave 36 divided by 16 like that for now. All right. When we're doing this method, you want to get something squared by itself first before you take the square root. Okay, everybody? Otherwise, it gets really messy. So we have x squared equals 36 over 16. And we can undo this squared, x squared, by taking the square root of both sides. But again, when you do it to these numbers, we have two answers here, both a positive and negative. So I like to put it in right away. The square root of x squared, they cancel each other out, so you're left with x. Then you have positive or negative square root of 36 over 16. And that's it. And I know some people are like, you could do something else. Yes, you could. And actually, this isn't simplified, so I'm going to take it over here. Notice that you're taking the square root of these two things. Well, what is the square root of 36? Well, the square root of 36 is 6. And what's the square root of 16? Because that's what we're saying, take the square root of 16. Well, that's 4, right? So we can actually take the square root of these two numbers, and notice and then you use up the absolute value. And now we've got positive or negative 6/4 makes this true. And you might even simplify it a little further and say plus or minus 3√2. 3 over 2. Okay. There we have it. We found our answer. We divided both sides by 16, and then we took the square root of both sides and simplified. You know, if you understand at this step, that's great. We will practice more where you keep going a little further. All right. I got the longer one out of the way first, I'm pretty sure. Okay. So now we've got x plus 3 squared equals 49. We can actually do things to both sides to get the x by itself. But if anyone's thinking we take away 3 from both sides, you really can't, because this is x plus 3 squared. So there's a lot more going on here than just plus 3, right? So instead of subtracting 3 from both sides, since this is all x plus 3 squared is all squared equals 49, what we're going to do is take the square root of both sides. Because we have x plus 3 squared, so that will cancel. And then we're left with x plus 3 equals, the square root of 49 is 7. Remember, we get a positive or negative 7 as our answer. And then, to get x by itself now, we undid that square. We just do that take away 3. So x equals positive or negative 7 minus 3. But, be careful. The square root of 49 is, when we take it, we get both a positive and negative answer. So you basically have two answers here. You have positive 7 minus 3 and negative 7 minus 3. So we do have two equations we have to solve. 7 minus 3 and negative 7 minus 3. 7 minus 3 is 4. Negative 7 minus 3 is negative 10. Okay, so we solved this in this method. We found that x equals 4 or x equals negative 10. And check it out. 4 plus 3 is 7. 7 squared, 49. Negative 10 plus 3, negative 7. Negative 7 squared, 49. Cool. So we'll do another one. So maybe you want to pause this one and try on your own. All right, so if something's squared, I'm going to undo it by taking the square root of both sides. That will cancel this squared out, so it releases the x minus 2. We got take the square root of 49, so we're going to do plus or minus the square root of 49. But we know that that is actually positive or negative 7. And then we add 2 to both sides. You get x equals positive or negative 7 plus 2. And we have two problems. We have positive 7 plus 2, which shoots out 9, and negative 7 plus 2, which shoots out negative 5. And those are what makes this equation true. And you can check it out. 9 minus 2 is 7. 7 squared, 49. Negative 5 minus 2, negative 7. Negative 7 squared, 49. Okay, 2 more, and then I'll tell you what your classwork is. So, the nice thing is, we can start doing things to both sides and not have to worry about factoring. Did you notice we didn't do any factoring on any of these today? We're just doing things to both sides. So, we got the next one, which is x plus 5 squared plus 10 equals 13. So, what are we going to do? Well, notice that this squared isn't by itself. So we want to get it by itself. That's what I showed you, or it gets really complicated. So what I'm going to first do is take away 10 from both sides. It's not in the parentheses, so I can get rid of it from there. And then I'm left with x plus 5 squared equals 3. And now we have something squared by itself, so we can take the square root of both sides to cancel out the squared. And then we're left with, I'm going to move it up here, the square and square root cancel out, x plus 5 equals, well, what is the square root of 3? Oh, remember, we get two answers, positive and negative. Well, the square root of 3 is irrational. It's not a whole number, so it never ends and never repeats, so we just leave it like that. And the last step is to subtract 5 from both sides. You get x equals positive or negative square root of 3 minus 5. You're like, Mr. Marion, what about this? And I said, that's the answer, actually. We got it. We locked it in. Because square root of 3 doesn't have an exact whole number answer, this is your answer. You get positive square root of 3 minus 5 and negative square root of 3 minus 5. And these aren't like terms, so we can't work with them. I will give it that teachers, I would accept this way. They want the number, this minus 5 first, so we're going to put it in front and then do plus or minus square root of 3. This is just some formatting old upper grade teachers get, but if you write it like this, I'll give you full credit, but this is what they look for later. There's probably a reason, but I don't know. All right, last example, ready? We got x squared plus 9, x squared plus 9 equals 0. Okay. There's no b term here, and we don't actually need it equal to 0, but let's get the x squared by itself, so we'll take 9 away from both sides. X squared equals 0 minus 9, negative 9. Then we can take the square root of both sides. And that cancels that out. And then x equals positive or negative square root of negative 9. Okay. Well, what is the square root of negative 9? What does that equal? Is it 3? Does 3 times 3 equal negative 9? No. Is it negative 3? Does negative 3 times negative 3 equal negative 9? No. So, well, this actually has no real solution. Your teacher should have talked to you about this before, but we'll talk about it now. You can't have, well, you can, but the square root of negative 9 is not a real number. For a long time, mathematicians didn't count it as anything. And you'll spend more time. So the square root of negative 9 is something called imaginary, but we're going to just say no real solution. And you're going to say, Mr. Ryan, that plus and minus, don't they go in here? I'm like, nope, that's separate. They're on the outside, not the inside. What is the square root of negative 9? There's no real solution for that. We have to make up a imaginary number. Okay, so classwork and homework for this week, for Wednesday and Thursday, boom, right here. Okay. I do have the answers included. You don't need to do these 4 and 5, but you're doing 6 through 12. The answers are there, so you can go ahead and solve it and see how you do with it, and let me know how it goes. Okay, I'll post answers to this one later and how all the steps to do it. But for now, there you go.